So the first part of Leaving Cert Applied Maths 2023 higher level question, or the paper rather, is this graph theory question. We're given the matrix for a digraph and we're just asked to draw it using these 6 nodes. Now, a key thing to remember with digraphs is that you start from here and you go to here. So for instance, A to itself, there's 1. Make sure to indicate with the arrows. Then from A to B, there are 2. So we're going to draw 2 going to B. From A to C, there's nothing. From A to D, there's 1. It's connected. And nothing else. Now, B is connected to C. And it is also connected to F. So B goes to F as well. Now, C is connected to A, B itself and D. So we're just going to do that. So it connects to A, connects to B, connects to itself, and also connects to D. It connects to E twice. So it goes here once, and then twice, and nothing to F. Now D is only connected to F. So D goes to F. E is connected to itself twice. So 1 loop and 1 loop. And then F is just connected to B. And that's roughly what it should look like. The next part says write down a cycle which starts at B. Well, if you go from B, you can head to C and then back to B. So one cycle could be B to C to B. How does a directed graph differ from an undirected graph? Well, if you look at the directed graph matrix here, it is not symmetrical about the leading diagonal. So all undirected graphs have an adjacency matrix which is symmetrical. So you could just say that all undirected graphs have an adjacency matrix along the leading diagonal. Now the second part is essentially just an integration by parts question as per the name. So let's just see my calculator, because there's going to be a calculation for this particular question. So it says a particle moving along a straight line has velocity v equals ds dt, which is 2t e to the minus t, where t is bigger than 0. And we're told to use integration by parts or otherwise, so pretty much just use integration by parts, to derive an expression for s of t, the displacement of the particle at time t. So we'll just write down the information that we do know, the information that we're essentially given. So ds by dt is 2t e to the minus t. So now multiplying across by dt, we arrive at ds is 2t e to the minus t dt. And now we're going to integrate. So the bounds of integration are that when t is 0, s is 0. And we're told to find a general expression for s and t. Now for this particular integral here, I'll write it over here. We have to do integration by parts. So we have u, dv, du, and v. So the u is going to be what comes first in the late rule, which is the 2t. Differentiate that, we get 2. The dv is e to the minus t. So integrating, we bring the minus down, so that's minus e to the minus t. Now we can say that the integral of 2t e to the minus t dt is u times v, so it's 2t, or minus 2t e to the minus t, minus the integral of v times du. Now, because this is a minus and a minus, I'm going to bring it out. So we just have 2e to the minus t in here, dt. Integrating this, we just bring the minus sign down. So that's minus 2t e to the minus t minus 2e to the t. Now, we can actually factor out a minus 2e to the minus t, and we get t plus 1. And that's our integral. Now, the integral of ds is just s. So s between 0 and s equals minus 2e to the minus t times t plus 1 between 0 and t. So this is just s equals, now evaluating this at t is minus 2e to the minus t times t plus 1, take away minus 2e to the 0 times 0 plus 1. Now anything to the 0 is 1, so I'm just going to go down. So anything to the power of 0 is 1. So because this is a minus, this is going to be minus 2. However, it's minus minus, so it's going to be plus 2. So we end up with s is minus 2e to the minus t times t plus 1 minus minus, so plus 2. And that is our general expression for the displacement of the body. And lastly, we're told to calculate s of 3. So this would actually be written as s of t. So s of 3 is minus 2e to the minus 3 times 3 plus 1 and then plus 2. Make sure this is all in a bracket so you don't get confused. So it's minus 2 e to the minus 3 times, well, 3 plus 1 is 4, and then plus 2. You should get an answer of about 1.6 meters to 1 place of decimal. And that's the answer to Leaving Cert Applied Maths Higher Level question 1.